In this lesson, we're going to look at solving linear systems by elimination when we have to multiply first. Example 1, how do I use multiplication when solving a linear system? So multiply the equation, then solve for the linear system. So first of all, let's take a look at the two equations that we have. They're both written in standard form. So since I can't solve the system through just simply adding or subtracting to cancel out one of the variables, we're going to multiply one of the equations or both of the equations by a number so that we can cancel through elimination. So if you'll notice here that I've got a 6x and a 2x, I could easily make the 2x a negative 6x by multiplying everything on the bottom by a negative 3. So if you're going to multiply any part, you've got to multiply all of the parts in order to get that. So we're going to multiply all of these terms. So I'm going to come over here and I'm going to rewrite 6x plus 5y is equal to 19. And then I'm going to have negative 6x minus 9y is equal to negative 15. And now notice that you can now cancel out the x's, and so then we'll solve for y and then plug it back in to solve for x. So 5y plus negative 9y is negative 4y is equal to positive 4. I'm going to divide the 4, or the negative 4, and y is equal to negative 1. All right, so let's come over here and we're going to then plug it back in. So we're going to pick one of the equations to plug the negative 1 into. I'm going to pick the second one right here, only because the numbers are smaller, but it really does not matter. So I have 2x plus 3, and now y is negative 1, is equal to 5. So 2x plus, I should say minus 3 is equal to 5. So we're going to add a 3. And so now we have 2x is equal to 8, and then we're going to divide, and x is going to be equal to 4. So the point at which the two equations are going to cross on the line is at the point 4, negative 1. All right, number 2, we have 4x plus 5y is equal to 35, and then 2y is equal to 3x minus 9. Now notice that our first equation here is written in standard form, but our second one isn't. So I'm going to just rewrite my first equation right here. And then I need to move my 3x to the other side, so I'm going to minus 3x. So I'll have negative 3x plus 2y is equal to negative 9. So now notice here that I cannot cancel either one of the variables out by adding and subtracting. So you'll probably notice for this one that we're going to have to multiply both of the equations by a number. So let's go ahead and I'm going to just pick the x's. It doesn't matter. I'm going to get those to cancel out. But I could certainly multiply everything by a 5 and a negative 2 or vice versa. So I'm going to multiply this by a 4. And I'm going to multiply the top by a 3. And now because the x's, I've got one positive, one negative, so I don't have to worry about multiplying by a negative here. So I'm going to have 12x plus 15y is equal to 105. And then now we're going to multiply the x by 4, so we have negative 12x plus 8y is equal to negative 36. All right, so now our x's are going to cancel out. I'll take 15y plus 8y, and I'll have 23y is equal to 69. And then now I'm going to divide by 23. And then we'll have y is equal to 3. All right, so now let's go ahead and we're going to plug it in to solve for the other variable. So I'm going to then, let's just kind of, so I've got, let's take the 4, and then we don't know x, plus 5 times 3 is equal to 35. So we have 4x plus 15 is equal to 35. We'll continue to solve. And x is going to be equal to 5. So the point at which these two lines are going to cross on the graph is going to be at the point 5, 3. So now we're going to take a look at some story problems. For number 3, it says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. So the first thing we need to do is we need to assign our variables. So let's go ahead and our x's, let's make those be equal to the envelopes. And then we'll have y equal to the paper. So in our first scenario, we have 3 boxes of envelopes. So we have 3x, and then we have 4 boxes of notebook paper, and that's going to be 4y, and that's equal to $13.25. And then we have 2 boxes of envelopes and 6 boxes of notebook paper, and that's going to equal to $17. All right, so now taking a look at the numbers we have here, it looks like we're going to have to multiply the top and the bottom by a number. So I think I'll multiply the top by 2, and then I'm going to multiply the bottom by -3. I need one to be a positive x and one to be a negative x. All right, so I'll have then 6x plus 8y is equal to $26.50. And then I'm going to have -6x minus 18y, and that's going to be equal to -51. All right, so the lesson doesn't get so long. I'm going to solve this, so you go ahead and pause the video and continue solving, and then resume to see if we get the same answer. All right, so when I went and solved, I found out that y was equal to $2.45. And so I plugged that into one of the original equations and found out that the paper then is $1.15. So envelopes, $2.45, and then the paper equals $1.15 each. All right, number 4, Mary has a collection of dimes and nickels worth $3.30. If there are 42 coins in all, how many of each kind of coin are there? So again, we're going to assign our variables. I'm going to say that x is going to be equal to dimes, and the y will be equal to nickels. All right, so then let's go ahead then, and we're going to say, first of all, there are 42 coins. So I'm going to say that I've got the dimes and I've got the nickels, and there's 42 total. And we know the dimes are worth 10 cents and nickels are worth 5 cents. So let's assign the money then to these variables. So for every dime, so I've got 10 cents, so 0.10x, plus our nickels then are 5 cents, 0.05. Don't get that confused with 50 cents, which is 0.5. And then I have a total of $3.30. All right, so let's go ahead, and we could multiply the top by either 10 cents or by 0.05, or we could multiply everything by 10 on the bottom, or a -10, so we get some whole numbers. So I'm going to go ahead and do that. So I'm going to multiply everything by, and I'm going to want a -1, so -10, and then I'm going to distribute that. So I'm going to have x plus y is equal to 42, and then I will end up with -x minus 0.5y, and that's going to be equal to negative 33. So notice our x's are going to cancel out. I'm going to continue solving. You go ahead and continue solving, and let's come back then to see if we get the same answer. So once we got done solving, you should have had 24 dimes and 18 nickels. Question number 5. You are selling hot dogs and sodas at a concession stand. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. How many hot dogs were sold and how many sodas were sold? So again, we're going to start by assigning our variables. So we're going to have x is going to be our hot dogs. And our y is going to be the sodas. All right, so let's then, let's do our total first. So I sold hot dogs, and I sold sodas, and I sold a total of 87 hot dogs and sodas combined. So then let's go ahead and assign the money. So the hot dogs were $1.50, and the sodas were 50 cents. And it looks like we made $78.50. All right, so I would start this one then. I'd probably multiply everything by, let's say, 0.5. Oh no, we made a negative so that those y's cancel out. So I'm going to solve this one. You go ahead and solve as well, and then let's come back and see if we get the same answer. And so after solving and then plugging in to solve for the other variable, we should have gotten 35 hot dogs and 52 sodas. All right, in our last question, number 6, it says Ashley had a summer lemonade stand where she sold small cups of lemonade for $1.25 and large cups for $2.50. If Ashley sold a total of 155 cups of lemonade for $265, how many cups of each type did she sell? And once again, we're going to start by assigning our variables. So we've got x will equal to small cups, and then y will equal to large. And so let's start by setting up the first one where you've got the small cups, the large cups, and we've got a total of 155 of them. And then we're going to go ahead and we're going to now assign the money. So I've got $1.25 for every small cup, and it ups $2.50 for every large cup, and then they ended up making $265. All right, so let's go ahead and let's multiply everything on the top by negative 2.5. All right, so we're going to do that, and then we'll should be able to eliminate a variable. So I'll go ahead and solve this one. I want you to solve this one and then come back and take a look to see then if we agree on the same answer. So when I solved, I got 98 small and then 57 large cups of lemonade. So in this lesson, we took a look at solving systems through elimination when you have to multiply first.